So let's begin with the motion in a straight line. So let's start with an example. Suppose it's early morning and this is me, this is my home, and there is this straight road in front of my home. Okay, and suppose that I wake up in the morning, I do certain things and I go for jogging, right? So I go along this way, along a straight line. Then there is this newspaper shop. I purchase a newspaper. Then again I keep on jogging, and there is this tea shop, my favorite tea shop. Okay, not a good thing to do in the morning after you jog, but suppose I take tea there and I read newspaper, and then I come back. Okay, and I stop over here. So now here are certain quantities to be described. So first is the distance covered. What is the distance covered in this path or in this journey? So suppose this distance from A to B is 5 kilometers, this distance is 3 kilometers. How much would be the distance covered? It is 5 plus 3 plus 3 plus 5, right? 16. Okay, 16 kilometers. That's too much, right? It won't be that much. Anyways, so suppose it is 16 kilometers, just for an example. Then, okay, nobody will jog for 16 kilometers. Okay, so let's suppose this is 500 meters, this is 300 meters. That is a good estimate. 500 meters, 300 meters. Okay, so this will be 800 meters along, I mean, one way it's 800 meters and one way it is 800 meters. So in round trip the total distance covered would be what? Yeah, 1.6 kilometers. That is good. All right, so then now how much would be the displacement? So distance is just the total length of the path covered, right? So it is 1.6 kilometers, right? 1600 meters. And displacement is the shortest distance between start point and end point of the motion. So what is the start point? A is the start point. What is the end point? A is the end point. So how much is the displacement here? Displacement is 0. No, displacement would be 0, no? If I start from A, I come back to A, displacement would be 0, right? Okay, good. Then, so this is displacement would be equal to 0. After that, suppose I start from A, go to this point C, come back, and that I give that newspaper back to the newspaper shop. Suppose I just have monthly subscription and I don't buy it. Okay, I just take it just for the sake of reading. Then these things are immaterial. I go till here and come back till here. Then how much would be the distance covered and how much would be the displacement? How much would be the distance covered? How much would be the displacement? Yeah, so distance covered would be equal to 1.1 kilometer. Good. And displacement would be equal to 500 meters, right? Because this distance is 500 meters. Yeah, very good. Yamini, Porna, very good. So this much is the displacement, just distance between the start point and end point, and the total length of the path is the distance. So that is 800 plus 300, that means 1100 meters, that is 1.1 kilometers, right? Then we define few more terms. So one is average speed. So what is average speed? It is the distance covered divided by time. Average speed is what? Distance covered divided by time. And next is average velocity. It is just the displacement divided by time. Okay, so average speed, distance covered upon time, average velocity, displacement divided by time, right? So now you must have noticed one thing, that the distance covered is almost always greater than the displacement. Okay, so suppose I start from here, I go till here. Then if I keep on walking along the same straight line and I never turn back, then the distance and displacement would be equal. Okay, but otherwise it will be always, the distance will be always greater than the displacement, right? So distance, so S is suppose displacement, d is the distance, so distance is always greater than displacement, okay? And that means if I denote average speed by u and average velocity by v, then average velocity will be always less than the average speed, okay? It's less than or equal to, it's equal to in only one case, when I start and keep on walking along the same straight line and I don't turn back, right? Then speed and velocity are equal. This thing's clear? Okay, very good. Then let's come to the types of motion. So there are two types of motion. One is the uniform motion, one is non-uniform motion. So what is uniform motion? The motion in which velocity remains constant. It is known as the uniform motion. Then what is non-uniform motion? The motion in which velocity changes. It's called as non-uniform motion, right? So then we define another term. Okay, all of these terms I think you know them. So next is the average acceleration. So suppose for an example, I start with velocity v1 and I end up with velocity v2. So v1 is velocity at time t1, v2 is the velocity at time t2. Then what is the acceleration? What is the average acceleration? Average acceleration would be equal to what? The final velocity minus initial velocity divided by final time minus initial time. Okay, v2 minus v1 divided by t2 minus t1. Right, it's very straightforward. Okay, and then we define a type of motion called as uniformly accelerated motion. Uniform motion means velocity remains constant, uniform acceleration. So the meaning is clear, right? It's uniformly accelerated means the acceleration is constant, okay? So this is motion of a body with constant acceleration. Okay, motion of a body with constant acceleration is called as uniformly accelerated motion. Very, very simple. Okay, so for this kind of motion, again, u is suppose the initial velocity, v is the final velocity, and acceleration is constant. So now we are not finding out the average acceleration, this is constant acceleration. Okay, so a is still equal to final velocity minus initial velocity divided by time, v minus u divided by t. And if you take this t on this side, okay, you get at equals to v minus u, or v equals to u plus at. So this is an equation, it's followed by a body which is moving with uniform acceleration, okay, which is doing uniformly accelerated motion. So that body follows this equation. This is called as the first kinematic equation. Okay, there are three kinematic equations. So this is first kinematic equation, v is equal to u plus at. The final velocity is equal to initial velocity plus acceleration into time, right? So this thing is clear?
Yes, sir.
Okay, very good. So then, all right, so then we'll talk about the other kinematic equations, but before that, just based upon this thing, let's try to solve some problems. Okay, so let's see this one. So we are studying motion in a straight line. Find the velocity, average velocity when particle complete circle of radius 1 meter in 10 seconds. So now, is this along a straight line? Of course it is not. Right, this motion is not along a straight line, but the concept of the speed and velocity, it's applicable here, right? Distance, displacement, speed and velocity, they are applicable everywhere. Okay, so this is basic thing. Find the average velocity when particle complete the circle of radius 1 meter in 10 seconds. So tell me, who will tell me? So option D, Yamini says option D. Everybody else is convinced, or do you think otherwise? It's not option D. Is it option D? Okay, very good. Right, so you know that. So when the particle completes one circle, the displacement is 0. That means velocity would be equal to 0, right? Average velocity would be equal to 0. Okay, v average would be equal to what? The displacement divided by time. So displacement is 0 when particle starts from A, comes back to A, and therefore average velocity would be equal to 0. Good. Then let us see next one. A runner starts from O and goes to O following the path OQRO in 1 hour. What is the net displacement and average speed? Tell me. Yes. Anybody? So runner starts from O and goes to O. What is the displacement? Displacement is 0. Starts from O and goes to O. So displacement is 0. So it's 0 in all of the options. So that's not what we want to find out. What's the average speed is the question. It's option C. Okay, let's check. All right, good. Everybody is saying option C. Right. So he goes from O to Q, Q to R, and R to O. Okay. So total circumference is equal to what? 2 pi R. This is 1/4 of the circumference, right? So the distance covered is equal to what? O to Q plus Q to R plus R to O. So that is equal to, I can say, radius plus this is 2 pi R divided by 4, right? This is 1/4 of the circumference plus radius. R to O is also radius. That is equal to 2R, and 2 you can take common. So it's 2 times R plus what? Pi by 4. Right? Or let's keep it like this: 2R plus pi by 2. Sorry, pi R by 2. Then we can put what is R. What is R? R is 1 kilometer. So, and all of the options are in kilometers per hour. So put R equals to 1 kilometer. So D is equal to what? 2 plus pi is 3.14 divided by 2. So 3.14 divided by 2 is 1.57. So 2 plus 1.57 is equal to 3.57. So this is distance covered. Time taken is 1 hour. Okay. So the speed is equal to distance by time. That is 3.57 in 1 hour. So it's option A, no? Right? Okay, good. So it's not option C, option A. All right. So this was very, very simple, right? Very simple question. Let's see next one. A wheel completes 2000 revolutions to cover the 9.5 kilometer distance. Then the diameter of wheel is. Tell me. A wheel completes. This is a wheel and it completes. It's going along a straight line, suppose. Like this. Okay. So when it completes one revolution, what will happen? So suppose it starts from this point. Okay. The wheel rolls, right? So it completes one revolution to go from A to B. So how much would be the distance from A to B? Anyone? So if it covers one revolution, means it will start from this point. Next, what will happen? If it rolls, then this point will come in contact. Yeah, it's equal to circumference, right? The next point will come in contact. The next point will come in contact. So if it revolves, okay, through one circle, then that means this point A, the same point of body, will come in contact over here. right? At point B also. So this much distance is equal to 2 pi r. Then it's very, very simple. So it completes 2000 revolutions to cover a distance of 9.5 kilometers. So you can say number of revolutions, n is suppose the number of revolutions. Let's check. Okay, number of revolutions. So n times 2 pi r is equal to what? 9.5 kilometers. But the options are given in meters. So let's convert this. It is 9500 meters, right? So n is 2000. So this is 2000 multiplied by 2 pi r. So pi is 3.14 and r is what? That's what we want to find out. Okay, or let's write it's pi d. So 3.14 multiplied by d is diameter. Okay, d is equal to 2r. D is equal to 2r. So then if we divide by this thing, what do we get? So this 9500 divided by 2000 will be 4.75, right? So you have d equal to 4.75 divided by 3.14. So it's nearly 1.5. Somebody said 1.5. 1.5 meters is the answer.
Sir.
Yeah, tell me. It's incorrect.
Sir, once show previous question, sir.
Previous question. This one?
Yes, sir.
Yeah.
Okay, sir.
No problem, no?
No, sir.
Okay. All right. Then let's see next one. A cyclist moving on a circular track of radius 40 meters completes half revolution in 40 seconds. Its average velocity is, okay, tell me, it completes half revolution in, so half revolution in 40 seconds. How much is the radius? Option B you are saying, Amini. Okay, let's check. So radius is equal to 40. This is given. Tell me others. Anyone? All right. So when it covers half revolution, what will happen? What will be the distance covered? Distance covered is pi r. Okay, for full revolution it will be 2 pi r. For half revolution it is pi r. Then what's the displacement? So the object goes from this point to this point. So what is the straight line distance? What's the displacement? It is just 2r, right? So displacement it's equal to 2r, okay, and therefore velocity is equal to what? 2r divided by time. That is 2 times r is 40 and in 40 seconds, so that means 2 meters per second. Yeah, so it's option B. Very good. So question is simple, right? Okay, good. Then let's see one thing, the conversion from kilometer per hour to meter per second. Okay, so conversion from kilometer per hour to meter per second. So 1 kilometer per hour is equal to what? Let's convert it, right? 1 kilometer is 1000 meters. It's 1000 meters. and 1 hour is 60 minutes, and each 60 minute has 60 seconds, so it is 3600 seconds. So if you divide this, okay, what will happen? So it's 10 by 36, or you can say it's 5 by 18. So 5 by 18 meters per second. Okay, so we need to remember this thing. Whenever we want to convert speed from kilometer per hour to meters per second, we'll multiply by 5 by 18. And if we want to convert from meters per second to kilometer per hour, it will be multiplied by 18 by 5. Okay, a simple thing, right? Okay, good. Then now let's see this problem. A car covers first half of the distance between two places at 40 kilometers per hour and another half at 60 kilometers per hour. The average speed of the car is. So now let me explain the solution of this, and this kind of problem is repeated. Okay, so let's discuss this. A car covers first half of the distance. So first half, so total distance is, suppose this is the car, it goes from A to C. Total distance is suppose S. So first half would be equal to S by 2. Next half would be also equal to S by 2. So distance AB is S by 2. Distance BC is also S by 2. Right? Then now we want to find out average speed of the car. So what is average speed? It is just total distance covered divided by total time taken. Okay. Of course, we know what is the total distance covered, right? Total distance covered we know, it's S. But do we know total time taken? We don't know, right? I mean, if S is total distance covered and V is some velocity, we can find out the time, right? So suppose it covers this half distance with speed V1. How can I say V1, sorry, what can I say? V1 would be equal to what? S1 divided by T1. The distance covered divided by time is T1. Okay, and V2 would be equal to the speed from B to C. It's equal to the distance covered, that's S2 divided by time is T2. Okay, so what would be the average speed? V average would be equal to what? Total distance, that is S, divided by total time is time from here to here. Time to go from here to here is T1. Time to go from here to here is T2. So total time is T1 plus T2, right? So then this thing, what is S1? S1 is also S by 2. S2 is also S by 2. So this thing will be S by 2 T1. This is S by 2 T1 and this is S by 2. Sorry, from here I will find out T1 and T2. T1 will be equal to what? S by 2 V1. Okay, if I take this T on this side, V on this side, so T1 will be equal to S1 by V1, but S1 is equal to S by 2. So T1 would be equal to what? S by 2 V1. And similarly T2 would be equal to S by 2 V2. I substitute that for T1 and T2. And then I can cancel out S in the numerator and denominator. Okay, so this is V average is 1 upon 1 by 2 V1 plus 1 by 2 V2. If I take reciprocal of this, what will I get? If I take reciprocal of this thing, see, I got V average is 1 upon 2 V1 plus 1 upon 2 V2, right? 1 upon 2 V1 plus 1 upon 2 V2. That's what I got. Okay, and if I take reciprocal of that, what will I get? 1 upon V average is equal to 1 by 2 V1 plus 1 by 2 V2. This is what we get. Okay, 1 upon V average is equal to 1 by 2 V1 plus 1 by 2 V2. Right, this thing is clear, everyone? Okay, so now we need to remember this formula. If body covers a certain distance, let's say distance S, so first half it covers with velocity V1, next half it covers with velocity V2, then what's the relation of average velocity with those two velocities? So 1 upon V average is equal to 1 upon 2 V1 plus 1 upon 2 V2, right? we need to remember this one. Okay, and for the sake of this problem, we'll simplify this. So what would be V average then? It's you can take this 2 which is in denominator of denominator to the numerator, and you simplify this thing. Okay, so you do cross multiplication, you write V2 here, V1 here, and in denominator you will have V1 V2, so that 2 times V1 V2 comes to the numerator. So the average speed becomes what? 2 times V1 V2 divided by V1 plus V2. Okay, it becomes 2 times V1 V2 divided by V1 plus V2. So for two bodies, remember it in this form as well as in this form. This thing is clear? Yes, no? Okay, very good. Then what is the first speed? That is V1, it's 40, and V2 is 60. So just put that over here. So average speed would be what? 2 times V1 V2. Okay, that's 60 times 40 divided by V1 plus V2. So 60 plus 40, that's 100. Okay, and then the answer that you get is, when you solve this, you will get 48 kilometers per hour. That's the answer, 48 kilometers per hour. It's option B. Okay, so this problem is very well understood, right, by everybody. Okay, so now let's see some problems which are like this. So a person traveling in a straight line moves with a constant velocity v1 for certain distance x and with constant velocity v2 for next equal distance. Okay, so you can say s by 2, s by 2. The average velocity v is given by the relation. Tell me, a, b, c, d. Yeah, it's option B. Very good. Okay, so we saw this thing, 1 upon v average would be equal to what? 1 upon 2 v1 plus 1 upon 2 v2. Take this 2 on this side, right? You can take 2 common from these two terms and move it over here. So this thing can be written as 2 upon v average is equal to 1 by v1 plus 1 by v2. Okay, very good. Very good, Yamini. So this thing is clear, everyone? Right. Then next, so now if the path is divided into n equal parts, okay, not just 2, the total path, the distance s is divided in n equal parts. Okay, and the body covers these distances, that is s1 s2, okay, which will be equal to s by n because you are dividing it into n equal parts with velocities v1 v2 v3 so on and so forth up to vn. Then you can write that n upon v average, okay, n upon v average is equal to 1 by v1 plus 1 by v2 plus 1 by v3 so on and so forth up to 1 upon vn. This is clear? Okay, we can extend the same formula, right? So remember this thing. So those two velocities is just special case of this thing. Okay, now let's see another problem. This is from NEET 2023 only. A simple problem. A vehicle travels half the distance with speed v and remaining distance with speed 2v. Its average speed is, you tell me. So you have option C. Okay, let's check. So 2 upon v average can be written as what? 1 upon v1 plus 1 upon v2, right? So that's equal to, or you could just use this formula, no? It's two body problem. So for, well, not two body, two velocities problem. So v average is just equal to what? 2 times v1 v2 divided by v1 plus v2. So that is equal to 2 times of v1 is what? V. v2 is 2v, and in denominator you will have v1, which is v plus 2v, right? So this will be 4v square divided by 3v, and that is equal to 4 by 3v. Good. So that's the answer, 4 by 3v. So this is clear. It's very simple, right? Okay, good. All right, then let's see this one. A car moves from x to y with uniform speed vu and returns to x with uniform speed vd. The average speed for this round trip is. So again, this is repeated problem, right? So its answer is option A, 2 times vd into vu divided by vd plus vu. Okay, so then let's see this uh, another case. Now see, they can ask uh, question like this. The body covers first half distance, okay, or let's suppose first 1/3 distance with speed v1, next 1/3 with speed v2, next 1/3 with speed v3. Okay, then you know how to solve that, right? Then 3 divided by v average would be equal to what? 1 upon v1 plus 1 upon v2 plus 1 upon v3. But now there is nothing which will stop them to ask a question like this. Suppose a car moves along a path of length s. First 1/3 of the distance is covered with velocity v1 and remaining with velocity v2. Find the average velocity. Then what will you do? So the trick is you can still apply the same formula. Okay, so as I said, it will be 3 divided by v average is 1 upon v1 plus 1 upon v2 plus 1 upon v3. So what I did is, this total distance is s. First 1/3 is covered with velocity v1, next 2/3 is covered with velocity v2. So what does that mean? So if you divide this distance in two equal parts, this much is covered, okay, this much is covered with speed what? v2, and this much is also covered with speed v2 only. So your v3 is also equal to v2, right? So that's the trick. So you can write 3 divided by v average is equal to 1 upon v1, okay, plus 1 upon v2 plus 1 upon v3, but v3 is also equal to what? v2 only. And then you can simplify this, okay? So this thing will be 2 divided by v2, and you can simplify this then. So it will be v2 plus 2 times of v1 if you do cross multiplication divided by v1 v2, okay, and then you can take its reciprocal and move this 3 on this side. So v average will be equal to 3 times v1 v2 divided by v2 plus 2 v1. This is clear, everyone? Okay, so now you don't remember this answer, you should be able to solve any problem which fits in this format, right? So they can say that a body covers certain distance, okay, so first 2/5 is covered with velocity v1, next 3/5 is covered with velocity v2. Then what can you do? You can divide, you can chop that distance into 5 equal parts, right? So v1 and v2 will be equal to v1 only, v3, v4, 5 will be equal to v2. So are you getting this, everyone?
Yes, sir.
Right, good. So you should be able to solve any kind of problem which fits in this format, okay? All right, then let's move on to the next topic. Next topic is uniformly accelerated motion. So now suppose I just want to plot the graph. We'll come to graph plotting or graphs for motion We'll see that in detail, okay, in maybe in next lecture. But for now, suppose I want to plot the velocity versus time graph for the uniform motion. So in uniform motion, the velocity is constant, right? The velocity is constant. So this graph will be a straight line. It will be just a horizontal line, right? It's parallel to time axis. So here velocity is constant. In uniformly accelerated motion, the acceleration is constant. So velocity keeps on increasing uniformly. So again, this graph will also be a straight line, okay, but it will have some slope, right? It has some slope. And how to find that slope? So see, on velocity axis, on this vertical axis, this is suppose the initial velocity v naught, this is velocity at some time t. So vt minus v naught will be what? It is the change in velocity, and this is the distance covered, or yeah, this distance on the time axis, it's what? It's the time, right? It's the time taken. So this much change on the vertical axis, it is change in velocity divided by this is change in time. So if you take ratio of that, you will get what? You will get acceleration. Change in velocity divided by change in time, you get acceleration, and that is the slope of this curve. Okay, that is the slope of this curve, right? This thing is clear? Okay, so this is the curve for uniformly accelerated motion. Okay, so the acceleration can be found by vt minus v naught divided by the time, right? And then we can do certain things using the slope. We can find out acceleration. Then using the area under the curve, we can find out displacement. But we are not going to do all of that. Okay, what we are going to do is we'll just take these three equations which we already know. Okay, so body which is in constant acceleration will follow these equations, right? So these are known as kinematic equations. Okay, so what are kinematic equations? So the body moving with constant acceleration follows kinematic equations. There are these three kinematic equations: v is equal to u plus at, s is equal to ut plus half of at square, and v square is equal to u square plus 2as. And in addition to that, I will write one more equation. Okay, these three are known as kinematic equations. If you want to find out average velocity of the body moving in uniform acceleration, the average velocity is just equal to v average is u plus v divided by 2. Okay, very simple relation. Average velocity is just equal to what? U plus v divided by 2. Okay, this thing is clear? Yeah. So any example of uniformly accelerated motion? Can you think of any example? Okay, an object thrown upwards, suppose, or an object which is released from some height or thrown downwards from some height. That is the object which is moving just under the force of gravity. It is a uniformly accelerated motion. Okay, object moving vertically in vertical direction just under the force of gravity, right? So an example is object moving in vertical direction under gravity. Okay, so let's consider specific case of that, which is known as free fall, right? So suppose you have this ball which is released from some height, it's released from this height and it's just falling. Okay, you have just released it, so it's falling under the gravity. So what is the acceleration acting on it? Here acceleration is equal to, now see, ball is moving in this direction, right? Ball is moving downwards and acceleration is also downwards, so we'll take acceleration as positive. So a is equal to g. Okay, a is equal to g, and initial velocity is equal to what? It's 0. So then for this ball, what can you say? Final velocity will be just equal to gt, right? At some time, final velocity v will be equal to gt, because u is 0. Okay, what will be s? What will be the distance covered? So s is equal to ut. So u is 0, so that is just half of gt square. Okay, and what about v square? V square will be just equal to 2 times g into s, and v square is just equal to 2 times gs, right? So these will be 3 equations followed by this ball or any object which is released, freely released under the gravity. This thing is clear, everyone? Okay, right. So here you have released a ball or an object and it's falling down, so it's moving downwards, acceleration is also downwards, so we took acceleration as positive because the motion and the acceleration, they are in same direction. Now suppose you are throwing the ball upwards. Okay, you throw the ball upwards, then what will happen? Tell me. An object is thrown upwards. An object is thrown upwards. Okay, then you can say its v will be equal to, see, v will be the final speed, u is some initial speed, right? So you can say v will be equal to u minus gt. Why minus g? Because it is moving upwards, acceleration is downwards, right? They are in opposite direction, so v is equal to u minus gt. Then the distance covered, so here the displacement, will say it is the height. The height is equal to, h would be equal to ut minus half of gt square. Okay, and next one is v square is equal to u square minus 2g, and the distance covered, we'll call it height. Okay, v square is equal to u square minus 2gh. This thing is clear, everyone? Right? Because the reason for this is motion and acceleration are opposite, are in opposite direction. Okay, therefore a is taken as minus g. That's it. It's very simple. Okay, and then there is one more thing which is very helpful, very helpful. So Galileo, who is also called as father of physics, okay, so he made a law, made means he discovered a law, that for any object which is moving in uniform, which is moving with uniform acceleration, the distances covered in times t1, t2, t3, if these times are equal, okay, by a body performing uniformly accelerated motion, are in the ratio of 1:3:5 if t1, t2, t3 are equal. Okay, the distances covered in equal times T1, T2, T3 are in the ratio of 1:3:5. So this is called as the Galileo's law of odd numbers. For an example, you release a ball, okay? You release a ball from some height, so distance covered in time T1 is suppose S1, then distance covered in time T2 when T1 and T2 are equal, right? All these times are equal. So the distances covered are in the ratio of 1:3:5:7. Okay, 1:3:5:7 and so on and so forth. So this thing is clear. This is known as the Galileo's law of odd numbers, and it will be very helpful. All right, so then this is from NEET 2022. The ratio of distances traveled by a freely falling body in the first, second, third and fourth second. Tell me. It's a direct question. It's option B. Good. Okay. Right, very good. It's option B. This is direct question based on the Galileo's law of odd numbers. All right. Then, so this is true for any uniformly accelerated motion, not just gravity. Okay. All right, let's discuss some questions based upon uniformly accelerated motion. A ball is thrown vertically downward with a velocity of 20 meters per second from top of a tower. It hits the ground after some time with velocity 80 meters per second. The height of the tower is, tell me. Anyone? Okay, what will you do? It's option D, 300 meters. Let's check. What did you do? How did you solve? Yeah, very good. V square minus U square is 2as. Okay, so you have ball thrown downwards with initial velocity 20 meters per second, and it hits the ground after some time with velocity of 80 meters per second, right? So U is equal to 20 meters per second, that's given. V is equal to what? 80 meters per second. Okay, and we want to find out the height. So you have V square minus U square is equal to 2as or 2ah we can say, because it hits the ground, and therefore h is equal to V square minus U square divided by 2a. Okay, a is equal to g, right, because it is thrown downwards. So V square minus U square can be written as V minus U, V plus U, and in denominator you have 2a. Then I will substitute values. So V is equal to what? It is equal to 80. So it is equal to 80 minus 20 multiplied by 80 plus 20 divided by 2 times of 10. So 80 minus 20 is 60. 60 times it's 100. Okay, 100 divided by 10 is 10. So that is 600 divided by 2. That's 300. So h is equal to 300 meters. This is the answer. Okay, this is very, very simple, right? Okay, then let's see next one. A stone falls freely under gravity. It covers distances h1, h2, h3 in first 5 seconds, the next 5 seconds and the next 5 seconds respectively. The relation between h1, h2, h3 is, tell me. Again, this is based on the Galileo's law of odd numbers. It is option D. Yeah, it's option D. Good. Everybody? All right, let me solve it. So you have h1 is to h2 is to h3 is 1 is to 3 is to 5, right? So if you want h1 is to h2, that's 1 by 3. Okay, so therefore if you take h2 on this side, you will get h1 is equal to h2 by 3, right? Similarly, h1 is to h3 will be equal to what? 1 is to 5, right? So it's 1 is to 5, and therefore h1 is equal to, you take h3 on this side, okay, so h3 divided by 5, and therefore you can write sorry, h1 is to h2 is to h3, or h1 is equal to what? h2 by 3, it's h3 by 5, right? That's option D. So this is clear, everyone? Okay, good. That's very, very simple, right? Because we know the law. Otherwise, you try it. Don't use the law and try it. Okay? How much time does it take? So, Galileo has made our life simple, right? All right. Let's see next question. A boy standing at the top of a tower of 20-meter height drops a stone. Assuming g equals to 10 meters per second square, the velocity with which it hits the ground is? Tell me.
20 meter per second.
20 meters per second.
Yes, sir.
All right, let's check. The boy just drops the stone, no? Okay. So h is equal to, okay, what will you use? The velocity at which it hits the ground. Yeah, v square is equal to 2 times g into h, because u will be equal to 0 when he just drops the stone, or v is just equal to, you can say, root 2 gh. Now you should remember this formula. V is equal to root 2 gh. Okay, if some object is just dropped from some height and it hits the ground with velocity v, then what will be that velocity? It's just equal to root 2 gh. Okay, directly remember this formula, no need to apply v square minus u square etc. Just remember this one, v is equal to root 2 gh. So that's equal to square root of 2 times of g is 10, 10 multiplied by height is 20. Yeah, so that's 20 times 20. Okay, so v is equal to 20 meters per second. Very good. So very simple problem, right? Okay, good. Then let's see next one. A particle starts its motion from rest under the action of constant force. Constant force means constant acceleration. Okay, so we know that force is equal to mass into acceleration. So if force is constant, means acceleration is constant. Okay, if the distance covered in first 10 seconds is s1, that covered in the first 20 seconds is s2, then now you tell me. Everyone? it's option B. S2 is equal to 4 times of S1. Everyone? Okay, so let me explain. So ball is dropped, right, and in first 10 seconds it goes till here. Okay, in first 10 seconds it goes till here. So let's call this height h1. H1 is equal to what? H1 will be equal to S1. Okay, this is in first 10 second in time t1. Then in first 20 seconds it goes till some height, sorry, it covers some distance. So let's suppose h1 is this one and h2 is this one. H2 will be equal to what? So you know this is covered in next t1 seconds or next, okay, next t seconds. So then this is equal to what? 3 times of s1. Okay, so they say that the distance covered, so let's say this is in 10 seconds and this is in next 10 seconds, in next 10 seconds. Okay, so first one is suppose h1 and next is suppose h2. So h2 will be equal to 3 times of h1, that is 3 times of s1, that you know. So they are saying the distance covered in first 20 seconds is equal to s2. So this total distance is equal to s2. Okay, this total distance is equal to what? S2. So how much is S2? S1 plus 3S1 means 4S1. Right? Okay, this is simple. Selva Kumar. Okay, very good. Then let's see next one. A ball is dropped from a height, sorry, not height. A ball is dropped from a high-rise platform at t equal to 0 starting from rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed v. The two balls meet at t equal to 18 seconds. So first ball is dropped. After 6 seconds, another ball is dropped from the same height. And two balls meet at t equal to 18 seconds. What is the value of v? Tell me. Tell me, what will you do? How will you solve this? Anyone? Indusha? Okay, so a ball is dropped from some platform, high-rise platform. Okay, and suppose it comes over here, then another ball is dropped at 6 seconds. And what's given? That after 18 seconds. So what's difference between these two? 6 seconds. After 18 seconds, these two balls meet at some height. Okay, so this is at 18 seconds. Right, this is at 18 seconds. So this is simple. Which thing is equal for them, both of them? So first, that blue ball was dropped from here. It comes till here in 18 seconds. After 6 seconds, this red ball is dropped. So which thing is equal for them? The distance covered is equal, right? Okay, it's option A. Let's check. Distance covered is equal. Okay, yes, no, Selva Kumar?
Yes, sir.
Okay, so then what is distance covered? So for the first ball, it is just equal to, so I can just say that S1 is equal to S2, and for first one, it's just equal to half of gt square. Okay, half of g into t1 square, because t1 will be equal to 18 seconds. Okay, it takes 18 seconds to cover this distance. What about second one? it gets just 12 seconds because it is dropped, not dropped, it is thrown after 6 seconds. So it is just getting 12 seconds, 18 minus 6, 12 seconds, right? So S2 will be equal to UT, it is thrown, plus half of, okay, UT2 let's say, plus half of G into T2 square, okay, and it's thrown with velocity V, so U is V. So then what we can do is we can move this thing on the other side, okay. So it's half of G into T1 square minus T2 square is equal to V times T2, and therefore what is V? V is equal to G into T1 square minus T2 square. So again I will write this thing as, this is G, okay, this is not 9. So T1 plus T2, T1 minus T2 divided by, you have that 2, and this T2 also I am taking from other side, right? And then you can substitute the values, okay. So what is T1 and T2? 18 and 6, right? So that's equal to G is 10, okay, G is 10 multiplied by 18 plus 6 multiplied by 18 minus 6 divided by 2 times of T2 is 12. No, T2 is 12, sorry. No, 18 plus 12 multiplied by 18 minus 12, right? T2 is 12. So 18 minus 12 is 6. 6 by 12 is what? 1 by 2, okay. So this thing is 30. 30 times 10 is 300. So we have 300 divided by 4. 300 by 4. That is 75. So V is 75 meters per second. Okay. Right, good. Okay, so Yamini is solving problems, others are not. Anyways, no problem. Let's discuss next one. Okay, a particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meters per second to 20 meters per second while passing through a distance of 135 meter in t seconds. The value of t is. Tell me, what will you do? So initial velocity is 10 meters per second. Particle is moving with constant acceleration. Initial velocity is 10 meters per second. Final velocity is 20 meters per second, and distance covered is 135. Okay, and they are asking you to find out the time. Anyone? See, that's simple, no? Okay, you have V is equal to U plus AT, right? So you know V, you know U. Do you know A? You don't know, right? So from this equation, V square minus U square is equal to 2AS. You can find out A, right? So find out A from that. V square is V minus U, V plus U, V minus U, V plus U divided by 2S. Okay, so put the values. So 20 plus 10 multiplied by 20 minus 10 divided by 2S. What is 2S? That is 2 times of 135. So this is 30, this is 300, 300 by 2 is 150, 150 by 135. So for now I am just keeping it 150 by 135. Okay, and from here we can find out the time. So what's the time? Time is equal to V minus U divided by A. V minus U upon A. So V minus U is 20 minus 10 divided by acceleration. Acceleration is 150 divided by 135. So that 135 will go into the numerator, 135. Okay, so that's 10. Okay, this thing becomes 10. So that is 1350 divided by 150 or that is 135 divided by 15, so that's 9, right? 9 seconds. That's the answer. This is clear? Yes, no? Everyone?
Yes, sir.
Okay, very good. But then now what I will do is I will solve this in 20 seconds. See how. So now this is a straightforward method. Okay, not to say that the other method that I am saying is not that straightforward. So we are used to doing this thing, right? This is initial speed, this is final speed, then if we have displacement, right, then we tend to use this formula, v square minus u square is 2as. But see, I wrote that fourth equation, if you remember if you remember. So average speed is given by what? U plus v by 2. That's it. Average speed is u plus v by 2. So how much is that? 10 plus 20 by 2. So that is 30 by 2 means 15 meters per second. So this is the average speed. How can you write down the average speed? It's the distance covered divided by time taken. So if you want time, that is just distance covered divided by average speed. So distance covered is 135, average speed is 15, 135 by 15 is 9 seconds. This thing is clear? Yes, no? Okay, so you can solve it very quickly, right? You need to remember all those formula, and most important thing is now we should be aware, okay, these three things are given: initial speed, final speed, and the distance is also given. That means time is required. So from this we can very quickly find out the average speed. Then time is just what? Distance covered divided by average speed. That's it. Okay, all right. So this is just to demonstrate that we can use certain tricks. Okay, but finally it depends on our state of mind mostly, and these tricks will keep on coming if you solve more and more problems. So okay, so now it takes me to the point, how many questions did you solve yesterday? Everyone, did you do the homework, the DPPs? And by the way, there is test on Sunday, so everybody has to give the test. Okay, all right, test based upon this much syllabus. Yeah, tell me, somebody raised the hand. No? The timing, it will be available from 12 p.m. okay, and I am just keeping it for your convenience. It will be available for entire week, but I mean, if you want to make it a habit, just give it on Sunday. That's it. Sunday 12 p.m. 13 p.m. is 1 p.m. etc. Choose your time and give it on Sunday if you want to make it a habit. Okay, all right, then let's see next one. The distance traveled by a particle starting from rest and moving with the acceleration 4 by 3 meters per second square in the third second is. Okay, so this is slightly different one. Distance traveled in third second. So suppose you throw an object, or it's in acceleration, so we can think like this: an object is thrown, okay, just acceleration is different. Okay, in first second it covers some distance, right, that is s1. In next second it will cover some distance, that is s2. In next second it will cover some distance, that is s3. Okay, so the total distance covered is suppose s3 in first 3 seconds. Okay, let's say s3 is the distance covered in 3 seconds. Distance covered in 3 seconds, right? And S1 is S2 is equal to distance covered in 2 seconds. Then what will be distance covered in third second? So distance covered in third second, distance covered in third second will be equal to what? Let's suppose S, it's equal to what? S3 minus S2, right? So it is just moving under constant acceleration and initial speed is 0. Okay, it's starting from rest. So this is just equal to half of g into t3 square, you can say, or time is just 3. Oh, not g. Acceleration is 4 by 3. Half of a into t3, that is 3 seconds, that square, minus half of a into 2 square. Okay, and then it's just equal to, see, half a you can take common, half a multiplied by 3 square minus 2 square, so that is 9 minus 4, right? So that's equal to half of a is 4 by 3, multiplied by 9 minus 4 is 5, so 20 by 6, how much is 20 by 6? Is 10 by 3, is 3.33. So 10 by 3 is there, so 10 by 3 is the answer. That's option A. Okay, this thing is clear, everyone? Okay, very good. So then now see, so a formula can be made like this. We can find out distance covered in last 1 second. Okay, object starting from rest, distance covered in last second. Okay, and you can just remember this formula. So see, so in 1 second, in n second, let's say Sn is the distance covered in n second, and Sn minus 1 is distance covered in n minus 1 second. So what would be the distance covered in last second? So distance covered in last second would be equal to Sn minus Sn minus 1. Okay, so that is equal to this thing will be equal to half of a into n square minus half of a into n minus 1 square, right? Now again a by 2 you can take common, so then it is n square minus n minus 1 square, so that is just equal to n plus n minus 1 multiplied by n minus 1, right? And that's equal to, you have 2n minus 1, and this n minus 1 is just 1. Okay, so it's a multiplied by 2n minus 1 divided by 2. Okay, let's call it S only. The distance covered in last second is a times of 2n minus 1 divided by 2. So this thing is clear. So for the last problem, just substitute a is equal to 4 by 3, n is equal to what? 3. Okay, because they are asking third second. They are asking about distance covered in third second, right? Okay, very good. So you can just remember this formula because they keep on asking these kind of questions. Okay, let's see next one. Two bodies, A of mass 1 kg and B of mass 3 kg, are dropped from heights of 16 meters and 25 meters respectively the ratio of time taken by them to reach the ground is? Tell me. Two bodies, A of mass 1 kg and B of mass 3 kg. It's option A. Yeah, correct. It's option A. Very good, Indusha. Okay, so we have this formula, no? H is equal to half of gt square, right? H is equal to half of gt square. Yes, no? A body just dropped. So you will have h1 by h2, okay? Or you can say that h is directly proportional to t square, and therefore you can say that h1 by h2 will be equal to t1 by t2 square. Okay, so then t1 by t2 is just equal to square root of h1 by h2. So t1 by t2 is just equal to root of h1 is to h2, and just put the values, right? So t1 by t2 is just equal to square root of h1 is 16, so 16 by 25, so that's 4 by 5. Okay, so that is very very simple, right? Sophia? Okay, this is correct. Okay, good. Let's see next one. A ball is thrown vertically upward. It has speed of 10 meters per second when it has reached 1/2 of its maximum height. How high does the ball rise? Tell me. Okay, so here you remember one thing, that if you throw an object upwards with some velocity, let's say 20 meters per second, it will go to some height. Okay, it will stop there. Stop there means not for this much time. Okay, its speed becomes 0, it comes back, right? And it hits back with the same velocity. Okay, it hits back with the same velocity. Now where does this thing come from? It comes from the conservation of energy. Okay, it comes from the conservation of energy, right? So the kinetic energy here becomes potential energy at height h. Okay, and then means according to law of conservation of energy, energy cannot be destroyed. Okay, so the body has same energy all the time, just kinetic becomes potential, and when it comes back, that potential energy gets converted to kinetic energy, right? So now you can remember it in this way. Suppose at any height a ball is thrown upwards. Okay, ball is thrown upwards from here, you're throwing it upwards, ball, any object. Okay, it goes to the height h. So now it was here, suppose. Okay, it was here at some time, and this is any height. Okay, you don't know. Then at this height it had some velocity. Okay, at this height it had some velocity. So time it takes to go from here to here, and time it takes to come back from here to here, it would be equal. Okay, time it takes, we can prove that time it takes to go from here to here, so from this height to the maximum height, and time it takes to come back from here to here, it would be equal. Also its velocity at this point would be equal in both cases, when it is moving upwards and when it comes back, the velocity at this point would be equal. Is this thing clear? Yes, no?
Yes, sir.
Okay, everyone?
Yes, sir.
Right? So then now can you solve it? Very easily you can solve. Okay, it now it has speed equal to 10 meters per second. How high does the ball rise? Okay, so now they are saying that it has gone till the height of 1/2 and its speed is equal to 10 meters per second, right? Height is h by 2, speed is 10 meters per second. Okay, how high will it go? So if it is released from here, it will come to this point. So let's say this distance is h by 2 now. Let's call this distance h by 2. Okay, it goes from here to here with some velocity 10 meters per second. So you can think of it like this: if it is released from here, it will come to this height, it will come this much down. Okay, and at that point its velocity will be same. So then you can apply v square is equal to what? U square, which is 0. Okay, if it is released from here, and then it's just equal to 2 times g into the distance s. And what is s? S is equal to h by 2. So it's 2 times of g multiplied by h by 2. Okay, so therefore g is 10. You can put that. So yeah, this will be gh, and what will be h then? H will be just equal to v square divided by g. So that's the answer. That is 10 square divided by 10 means 10 meters. This is the answer. This thing is clear? Everyone?
Yes, sir.
Right? Okay, so just remember these two things. If you throw some object with some velocity, okay, when it comes back to the same point, its velocity would be equal. Second thing is the time that it takes to go from there, okay, to the highest point is same as that of time it takes to come from that highest point to this point. Okay, two things, right? And actually we'll see that in projectile motion, the time it takes for upward journey is equal to time it takes to go downwards, okay, for the downwards journey. All right, let's see the next one. If the ball is thrown vertically upwards with speed u, the distance covered during the last t seconds of its ascent is? Ascent is, it is called as ascent, no, or it is ascent? I think there is a spelling mistake. Or is that fine? Anybody who is good with spellings? It is just called as, I think it is just called as ascend. Okay, ascend is correct, but is ascent correct? It is ascend, no? Okay, it's ascend only, it's moving upwards. All right, so last t seconds, how much distance will it cover? Tell me. It's option B, okay, as I just explained, right? This thing is clear? Okay, yeah, very good. All right, let's see next one. A particle is thrown vertically upward. Its velocity at half of the height is 10 meters per second. Then the maximum height attained by it. Tell me. Particle is thrown vertically upward. Its velocity at half of the height is 10 meters per second. Then maximum height attained by it will be? It's the same question, no? Particle is thrown vertically upward, its velocity at half of the height is 10 meters per second, then the maximum height attained by it. Yeah, same question. Is the year same? No, that's 2005, this is 2001. Okay, so we just found the answer for this. It is 10 meters, right? Okay, it's the same question. All right, let's see next one. A car moving with speed of 40 kilometers per hour can be stopped by applying brakes after at least 2 meters. Okay, if the same car is moving with the speed of 80 kilometers per hour, what will be the minimum stopping distance? So here you will assume that when you apply brake, you are applying the same force. That means the acceleration would be equal in both cases, right? Actually it is negative acceleration because you are applying brakes. Tell me. What will you do? Okay, here see, when you apply brakes, it's option C. Okay, let's check. 8 meters. It might be true. Let's check. Okay, so when you apply brakes, v square is equal to, you know, u square minus 2as. Why minus? Because acceleration is negative. Okay, a is negative, right? Or you can say that v square is u square plus 2as, but this value of a would be negative. Either you can take negative sign there, or you can just write v square is equal to u square minus 2as, right? So then v square, v would be equal to 0, and that means u square is just equal to 2as. So in the first case, its u1 square would be equal to what? 2as1, and in second case, its u2 square should be equal to 2as2, right? And you can just cancel out these things. So you have u1 by u2 square. u1 by u2 square is equal to s1 by s2. Okay, and that is, what is u1? It's 40. So 40 by 80 square is equal to, s1 is 2, s2 is, we don't know, we need to find it out. So this is 4 by 8 means 1 by 2 square. 1 by 2 square is 1 by 4. Yeah, so 1 by 4 is equal to 2 by s2. So s2 would be equal to 8. Good, it's 8 meters. Okay, this is also simple, right? Everyone? Okay, that's very simple. So if there is a problem based on stopping distance, just directly you can write that u1 by u2 square will be equal to s1 by s2. Okay, u square is directly proportional to s. This is the formula. Right, u square is directly proportional to s. All right, so then there are similar problems. So like if a car at rest accelerates uniformly to the speed of 144 kilometers per hour in 20 seconds, it covers a distance of, this is very simple. Here you need to apply what? Starting speed is 0, so v square is just equal to 2as, and you want s, it will be equal to v square by 2a. Just convert that v, which is 144 in kilometers per hour, to meter per second. So multiply it by 5 by 18, right? And what is this thing? 144. Is it there in the table of 18? Yes, it's 18 8s are 144, right? 8 5s are 40. Okay, so then this is 40 meters per second, and then you can substitute values. So 40 square divided by 2 times a. Okay, oh, a car accelerates uniformly to speed of this much in 20 seconds. Okay, so v is equal to u plus 80, you know. So v is equal to u plus 80. U is 0, so it is just equal to 80, and from that you find out a. So a is equal to 40 by time is 20, so a is equal to 2. You substitute that 2, right? This is 40 square, that's 40 into 40 divided by 4, so that's 400, right? 40 by 4 is 10, 10 times 40, 400 meters. So this is the answer. Okay, this thing is clear? Yes, no? Everyone?
Yes,
Yes,
sir.
sir.
Okay, good. So now maybe, just maybe, I don't know, if you are something like me, you don't remember the tables, because I don't remember the tables. Okay, most of them. Okay, after 10, 11, it's difficult for me. Okay, so then what you can do, you want to find out 18 eighths are, what will you do? So I can just write this thing as, okay, I can do this in two ways. So it is 20 minus 2, 18 is 20 minus 2 times 8. Okay, 28s are what? This thing is doable, right? 28s are 160 minus 2 8s are 16. 160 minus 16 is 144. This thing is clear? Yes, no? Okay, another way to do, 18 8s are 18 times 10 minus 2, right? So that's 180 minus 18 2s are 36, so that is 144. So if you don't remember the tables, you can do this thing. Okay, because multiplying 18 with 8 will take some time. Doing these things don't take that much time. And actually I didn't remember what is 18 eighths. Okay, so what I did in mind when I said yes, it's that. Okay, 18 eighths are 144, so I did this second thing. Okay, you won't believe, but I did that thing. So this is a neat trick, okay, which will be helpful in NEET. Anyways, this is clear, everyone, how to do calculations if you don't remember the tables? Okay, good. Let's see the next question. A body dropped from a height h with initial velocity 0 strikes the ground with velocity 3 meters per second. Another body of same mass dropped from the same height h with an initial velocity of 4 meters per second. The final velocity of second mass when it strikes the ground is, tell me. So first body is dropped from height h with initial velocity 0, strikes the ground with 3 meters per second. Okay, another body of same mass dropped from the same height, that mass does not matter, with initial velocity 4 meters per second. The final velocity of second mass, tell me, when it reaches the ground is. Sorry. Okay, that's simple. See, first body's final velocity is what? 3 meters per second. What does that mean? So v is equal to, you know, it's root 2 gh, or you have v square is equal to 2 gh. So from this you can just find out the height. Okay, you can just find out the height. So let's call it v1 because it is for first mass. So height would be equal to v1 square by 2g, right? And then what is v1? It's 3 meters per second, so it's 3 square by 2g. 2g means 2 times 10. Okay, so 20, 9 by 20. So you got the height, and then second mass is thrown. It's thrown with this much velocity, right? Initial velocity is 4 meters per second. So what would be the final velocity? That's the question. So you have v square is equal to u square plus 2gh, and there we can put the values. So it is 4 square plus 2 times of 10 into 9 by 20. Okay, so this 20 gets cancelled out. 4 square is 16. 16 plus 9 is 25. So v square is 25. So v is just equal to 5 meters per second. Okay, so this is the answer. Right, very, very simple. Okay. I'm sorry. Let's see another question. the water drop falls at a regular intervals from a tap 5 meters above the ground. The third drop is leaving the tap at the instant the first drop touches the ground. Okay, drop number 1 comes down, drop number 2 comes down, then drop number 3 just comes out of the tap. At that time the drop number 1 touches the ground. This is given. Okay, how far above the ground is the second drop at that instant? How far above the ground is the second tap second drop at that instant? This is the question. Tell me. So drop number 1, this is drop number 3. Okay, it's option D. Let's check. This is option D. Is it option D? All right, so this is drop number 3, this is third one, this is second, and this is first. First one reaches the ground. Okay, this is first, right? And the drops are falling after regular intervals. Okay, so interval is fixed. Let's say 1 second. So at 1 second first drop is coming, sorry, at the 0 first drop is coming, 1 second second drop is coming, okay, 2 seconds third drop is coming, right, like that. So the distance covered by this one and distance covered by this one, what would be the ratio of that? Tell me. So this much distance is covered. Suppose second drop gets 1 t, right? So this is t, distance covered by the first drop. So first drop would get 2t, right? Okay, so this distance is suppose s1, therefore distance covered by second drop, this is s1. This distance would be equal to what? Let's call it s. So this distance and this distance, what will be the ratio of that? So we know s1 is to s2 is what? 1 is to 3. So s2 is equal to 3 times of s1. That means total distance s, or you can say the height, this is the total height, h is equal to s1 plus s2, right? s1 plus s2. So that is s1 is s1, s2 is 3s1, right? s1 plus 3s1, that is 4s1, and therefore what will be, yeah, this total distance is 4s1. That means what will be s1 is, it's h by 4. Okay, so that's 5 by 4. 5 by 4 means 1.25 meters. So this distance is 1.25 meters. So how high this second drop is above the ground? Tell me. Is it 1.25? No, 1.25 is this distance. Yeah, it's 3.75. Very good, Yamini. It's 3.75, right? So how high is the second drop? So S2 is just equal to h minus what? S1. That's 5 minus 1.25. So that is 3.75 meters. So this is the answer. Okay, this is clear. So this is good question. Again based on Galileo's law. Okay, so Galileo is big saver, right? All right. So then I guess other questions would be similar. Yeah, other questions are similar, so you can just try them. Let's see this one. The velocity of a train increases uniformly from 20 kilometers per hour to 60 kilometers per hour in 4 hours. The distance traveled by the train during this period is very simple, right? And we don't even need to change the units from kilometers per hour to meters per second, because the time is also given in hours, right? So Tell me, how will you solve this? It changes from 20 to 60 in 4 hours. So just find out the average velocity. Average is what? 20 plus 60 divided by 2. How much is that? 80 by 2. So 40 kilometers per hour is the average. And the distance covered is just equal to V average multiplied by time. So that is equal to 40 multiplied by time is 4 hours. So it's 160 kilometers. This is the answer. Okay, either you can do this way, which is the quickest one, right? Or what you can do is you can find out the acceleration. So acceleration is equal to what? V minus u divided by t. So 60 minus 20 divided by t is 4. So 60 minus 20 is 40. 40 by 4 is 10. Okay, but that is in kilometer per hour square, not meter per second square, right? That is the acceleration. Okay, and then the distance s is equal to, you can say ut plus half at square. Either this formula you can use, or you can use this formula. V square is just u square plus 2as. Okay, put the values. So u square is 20 square plus 2 times of 10 multiplied by, no, we want distance, no? So s only, sorry, s is ut plus half at square. Ut plus half at square. So that is u is what? 20 times t is 4 plus half of a is what? 10 times 4 square. So either way you will get the same answer, but this thing will take some time. Okay, and that's why presence of mind is important. So this is 80 plus this is 4 square is 16. 16 times 10 is 160. 160 by 2 is 80. So 80 plus 80 is 160 kilometers. Okay, so answer will come out to be equal, but this will be much faster, right? So this thing is clear, everyone?
Yes, sir.
Okay, so all right, so now so first of all let me say that you need to solve problems. Okay, whatever practice problems are provided every day, you need to solve them. Okay, if you are not doing that, then attending just the lectures, it will not be that much fruitful. Okay, so let me get it very straight. If you just attend the lectures and you go for the exams, then your improvement is suppose 10%. Okay, so let's suppose it is 1. Okay, let's take some scale. Improvement is 1. Then if you attend the lectures and practice the problems and also solve the test, okay, then it will be 100. That much is the difference. Okay, so practicing and solving the test is very, very important. Okay, so I will not suggest, I will advise not to skip the test, not to skip the practice. Okay, so please practice it, right? And now there is another course on the website. So course is called as test series. Okay, so there is some price to that course, but I will just send you a coupon code. Okay, just put that coupon code and place an order. Okay, today or tomorrow. Then the price will come down to 0, because the course is included in this thing only, the crash course. Okay, and please attend the test. Okay, so now you can say that's my suggestion, that's my request, and that's my advice, everything. All right, so we'll stop here. There are 2-3 problems which you can try right away, I mean when I forward this, and after that I will be sending the homework questions. So I will say which problems to be solved, okay, which will be based on this thing. So the test syllabus would be whatever we covered in this week, right from the beginning.